Okay, so the purpose of this section is to study how errors in numbers propagate through functions. So, for example, if we have two numbers that have errors in them, as engineers, we are interested in estimating the error in the product of these two numbers. So suppose we have some function f of x, and we approximate, well, it only depends on one variable x, and if we assume that x tilde here is the approximate value of x, then how do we assess the discrepancy between these two numbers? In other words, what is the difference between delta fx tilde? So that is f of x tilde minus f of x. Now the problem with this statement is that we don't know what f of x actually is. So let's just draw this with a graph. So if we have a function, we've drawn that here in blue, f of x, and we now estimate, we use the derivative we use x of I plus 1 and x of I to get the derivative. But we want to know what the approximate value of x tilde is, somewhere between xi plus 1 and xi. So we use the derivative and we end up with a value that we can see quite clearly is different. So f of x is approximately equal to f of x tilde, but it's not, right? It's a numerical approximation. So we have this discrepancy between f of x and x tilde, which obviously means we have a discrepancy in our function value. So now we're interested in looking at how the error in the product of these two values propagate through our model. Now we can overcome this again if we assume that x tilde is close enough to x and that the function value of x tilde is continuous. So what I mean here is if we had to, we've got x tilde here, the actual value of f of x tilde, so is going to be somewhere here, and this is actually f of x. That is x. So, if x tilde is continuous and differential at that point, and if it's true that we can use, then we can use the Taylor series to compute the value of f of x near f of x tilde. So we can write that the function value f of x is equal to f of x tilde plus the derivative of x tilde multiplied by the step size. So in other words, the difference, so we just rearrange this between f of x and f of x tilde is approximately equal to the derivative multiplied by our step size, which we can then rewrite by saying the difference, so delta f x tilde is equal to the absolute value of the derivative at x tilde multiplied by our step size. So here we can see that our error term is proportional to our step size.